Department of Electronics and Communication Engineering. Today I am going to explain you about the properties of DFT from the subject of digital signal processing. In the last session I had explained you the basic concept of DFT and IDFT, right? Now the next topic is properties of DFT. In this, first property is linearity property. Now as you know that for defining any property, first of all we starting with the statement of it, right? So what will be the statement for this linearity property? Suppose if I am taking the two signals x1 of n and x2 of n and I am finding the DFT of it, then it will converting in the form of x1 of k and x2 of k, right? So if I am taking this, then what is the linearity property? Linearity property means it will follow the superposition principle. So what is superposition principle? In the time domain, if I am taking a1 x1 of n plus a2 x2 of n, then it will gives you the corresponding seen in the frequency domain as a1 x1 of k plus a2 x2 of k, right? So now this one is the statement of this linearity property. Now if you want to prove this property, then as you know that we start in proving any property by taking the equation of it. So starting with n point DFT. So if I want to find out n point DFT, then the equation is x of k equals to summation n equals to 0 to n minus 1 x of n into wn raised to kn, right? If I am writing in the form of Twitter vector. Now same way n point DFT is considered as DFT of x of n. So if I am finding DFT of x of n, its value equals to this, right? But now we have to find out DFT of this term and we have to derive its value equals to this term, right? So I am starting with this DFT of a1 x1 of n plus a2 x2 of n, then the value equals to summation n equals to 0 to n minus 1. Instead of this x of n, I am putting this value. So the term will be a1 x1 of n plus a2 x2 of into wn raised to kn, right? Now as you know that if I am writing a plus b into c, then what will be the value? ac plus bc. So by using this formula, we will apply this rule over here, then the term will be summation n equals to 0 to n minus 1. a1 is constant, so it will be outside of this summation x1 of n into wn raised to kn. The same way this a2 is constant, so it will be outside of this summation n equals to 0 to n minus 1 x2 into this. So x2 of n into wn raised to kn, right? Now we can compare this equation with this equation. So this one is DFT, so its value is equals to xk, right? Here if we are taking x of n, then it will give you x of k. But here we are taking the value x1 of n, so this will be representing as x1 of k. This term will be as it is, same way this constant a2 is as it is, and this term will be representing as x2 of k. So this way we can prove the linearity property of this DFT, right? Now the next property is periodicity property. What is periodicity property of this? So if we are writing the statement for this, then what is the statement? What is periodicity? After n number of samples, it will be same as the original sequence, right? So if I am applying this periodicity property, then the statement will be if x of n is convertible in form of x of k, if I am taking DFT, then what is periodicity condition? X of k plus n equals to x of k for all values of k. So starting with this, if I am writing proof of it, then what is the proof? If I am finding DFT of x of n, then what will be the value? X of k, its value equals to summation n equals to 0 to n minus 1 x of n wn raised to kn, right? Instead of this x of k, we have to find out x of k plus n, right? So I am replacing k by k plus n. So here instead of k, I am writing k plus n. So what will be the value? X of k plus n equals to summation n equals to 0 to n minus 1 x of n wn raised to, instead of this k, I am writing k plus n into n, right? Now if I am finding this x of k plus n, then what will be the value? Summation n equals to 0 to n minus 1. Now what is the value of this? Wn raised to kn into wn raised to nn into this x of n, right? Now if we want to prove this property as x of k plus n, it should be equals to x of k. So what is the value of x of k? X of k equals to this term, right? So this term representing x of k. This should be multiplied with this factor. It means it should be equals to 1, right? Now if we are deriving the value of wn raised to nn, then what is the value of wn raised to nn? Its value is, what is the value of wn? Wn means e raised to minus j to pi by capital N, right? Into n into n. Now if I am cancelling this n, then the value equals to e raised to minus j to pi n. Now if I am finding the value of this, then the value is cos 2 pi minus j sine 2 pi n, right? Now as you know that if I am taking n equals to 0, n means what? N means number of sample. It will be always in the form of integer. So we can take the value of n equals to 0, 1, 2, 3 likewise. So if I am taking any value of n, then the value of cos 2 pi n will be equals to 1 and the sine 2 pi n equals to 0. So overall the answer of this equals to 1. So if I am putting, instead of this term, if I am putting n 1, then this value equals to 1 into this term. Means it will give you the term as n summation n equals to 0 to n minus 1 x of n wn raised to kn, right? And what is this term indicating? It indicating x of k. So this way we can prove that after n number of samples, this will be same as original sequence x of k. So this is your periodicity condition of DFT. Now the next property is time reversal of a sequence. Now what is the meaning of time reversal? Time reversal means folding, right? So if you want to write down folding of a sequence, then how will representing it? Starting with statement, if I am writing x of n will be convertible in x of k. If I am taking DFT of it, then what is time reversal? Time reversal means folding, right? So what will be the term? X of minus n, and it will be in the circular form. So we are writing over here after n number of samples, it will be in the repeating form. So this will be also representing as x of n minus n, because as you know that after n number of samples it will be same. So if I am writing x of minus n, so after n number of samples this will be same as x of minus n, right? So over here, instead of this x of minus n, we have taken x of capital N minus small n. So this way we can take the time reversal of a input sequence. So if I am taking time reversal in the input sequence, then corresponding to it, what will be in the form of DFT? Its value will be x of minus k after n number of samples. So it will be representing as capital N minus k. So this is your time reversal property of any sequence in the DFT. Now if you want to prove this property, then what will be the proof? To prove this property, we'll starting with the equation of DFT. What is the equation of DFT? If we'll finding DFT of x of n, then it will gives you the answer of x of k, and the value of it equals to summation n equals to 0 to n minus 1 x of n into wn raised to kn, right? Now instead of this x of n, if we'll taking x of n minus n, then it will also same, because after n number of samples it will be in the repeating form. So instead of this n, I am taking n minus n. So what will be the value? Summation n equals to 0 to n minus 1 x of n. Instead of this n, I am taking n minus n, right? So if I am simplifying this, then what will be the term? Summation n equals to 0 to n minus 1 x of n wn raised to kn into wn raised to minus kn, right? So if I am finding this value of this term, then what will be the value? wn raised to capital Kn, its value equals to, it will be in the form of, this will be term, this term will be representing in the form of wn raised to kn, means e raised to minus j 2 pi by capital N raised to k into n, right? So n will be cancelled out, and as we will changing the value of k from 0, 1, 2, 3, so for any value of k, the value of this term equals to 1. So over here, if we will putting this value equals to 1, then what will be the value? Summation n equals to 0 to n minus 1, x of n into 1 means x of n into wn raised to minus k. Now this term should be representing in the form of wn raised to kn. So I will write down like this, minus k into n. So if I am writing k, then this term will representing as x of k, right? Here we are representing in the form of minus k, so this term will representing as x of minus k. So this way we can prove this time reversal property. Now the next property is circular time shift of a sequence. So starting with the statement of this, what is the statement for this property? If I am taking x of n and finding DFT of it, then it will gives you the answer as x of k, right? So what is circular time shift of a sequence? Then x of n minus l, it will shifting by l number of samples, it will be repeating after n number of samples, then DFT of it equals to x of k into e raised to minus j 2 pi kl by capital N. So to prove this term, we are starting with the equation of IDFT. What is the equation of IDFT? X of n is equals to 1 by n summation k equals to 0 to n minus 1 x of k into wn raised to minus kn, right? This term will also representing in the form of wn, so it will be representing as wn raised to kl, right? So if we will multiplying x of k with wn raised to kl, so this term will be representing as x of k, it will be multiplied with wn raised to kl, so this term will be wn raised to minus kn. This will be considered as summation k equals to 0 to n minus 1, 1 by n. So what will be the value of this term? It will be representing as summation k equals to 0 to n minus 1 x of k, and this term will representing as wn, will taking the minus k part as common. So this term will representing as n minus l, minus minus plus l, right? Now if I am writing this term as n, then this term will representing as x of n minus l. So if I am taking x of n minus l, it will gives us answer equals to this term. So x of n minus l will representing as this term, right? So this way we can prove the circular time shift of a sequence. Now the next point is very important point, which is circular convolution. What is the property of this? As you know that if we convolve two sequences in the time domain, then the corresponding to its multiplication in the any another domain. Now, like if we will taking in the frequency domain, so it will be gives you the multiplication in the frequency domain, right? So what is circular convolution property? For that, if I am writing statement of it, then the statement will be like this. If I am taking x1 of n and x2 of n, these two sequences, and I am finding DFT of it, then what will be the DFT of it? x1 of n will convertible into x of k and x2 of n will convertible into x2 of k. Then if we are taking x1 of n circular convolution with x2 of n, it will be representing as n point circular convolution. So if I am finding DFT of it, then the value will be x1 of k into x2 of k, right? So now if we want to prove this property, then we'll starting with the equation of convolution. What is the equation of convolution? One signal as it is, another one is folded, shifted, multiplied, and then summation, right? So we're taking summation n equals to 0 to n minus 1, x1 of n, x2 of n minus n. This one is after n number of sample, it will be in the repeating form. So first term is as it is, second term is folded, shifted, then multiplication, and after that it will give you the summation. So this one is the equation of circular convolution. So if we are writing the equation of x1 of k, then what will be the equation of x1 of k? x1 of k equals to summation n equals to 0 to n minus 1 x1 of n into e raised to minus j 2 pi kn by capital N, right, from the equation of DFT. Same way, if you want to find out x2 of k, what will be the value of it? X2 of, instead of this n, we will taking L, any another variable, because we will not mixing this two signals, right? So we will taking any another variable like x2 of L. So the value of L is in the range of L equals to 0 to n minus 1 e raised to minus j 2 pi kl by capital N, right? Now if you want to find out the output, then what is the value of output y of k? The value of output y of k equals to x1 of k into x2 of k. Now if you want to find out the output sequence y of n, what is the value of y of n? By taking inverse DFT of this term. So if I am taking inverse DFT, then the term will be y of k 1 by n summation k equals to ranging from 0 to n minus 1. Over here, instead of this n, L will taking the another term as e raised to j 2 pi km by capital N. Right. Now, if I am putting the value of y of k, what is the value of y of k? Y of k equals to x1 of k into x2 of k. So I am putting these two values over here. Then the value of y of n equals to 1 upon n summation k equals to 0 to n minus 1. Instead of this, we will putting x1 of k and the value of x2 of k. So what is the value of x1 of k? Summation n equals to 0 to n minus 1 x1 of n e raised to minus j 2 pi kn by capital N into summation L equals to 0 to n minus 1 x2 of L e raised to minus j 2 pi kl by capital N into the value of this one is y of k, right? So we'll writing e raised to j 2 pi km by capital N. Now if we are simplifying this, what is the rule? If there is more than one summation, integration or summation, then we'll interexchanging the order of this, right? So what will be the term? 1 by n will be, as it is, this summation goes over here, so summation k equals to 0 to n minus 1. This summation we'll writing first. So summation n equals to 0 to n minus 1 x1 of n, summation L equals to 0 to n minus 1 x2 of L. Now we're putting these three terms over here. So the value will be e raised to minus j 2 pi kn by capital N, e raised to minus j 2 pi kl by capital N into e raised to j 2 pi km by capital N, right? Now we're simplifying this three term as e raised to j. Common, we'll take in common part a plus b plus c or a minus b minus c likewise. So we'll representing this in the form of 1 by n summation n equals to 0 to n minus 1 x1 of n. This term will be representing as summation n equals to 0 to n minus 1 x2 of L. This will be representing as summation k equals to 0 to n minus 1. Now this term will representing as e raised to j 2 pi k by capital N. Now we're taking this term as an n minus this n, right? Now we're simplifying this term. As you know that if there is summation is given to you, then we will converting this in the form of a raised to n. As this term is summation of k, so I am representing this in the form of a raised to k. So what is the value of a raised to k? All the other terms will remain as it is 1 by n summation n equals to 0 to n minus 1 x1 of n summation L equals to 0 to n minus 1 x2 of L and summation k equals to 0 to n minus 1. Now what is the value of a? Its value is e raised to j 2 pi. This k will be over here, so the term will be m minus n minus L divided by capital N, right? Now if we'll applying the rule of this, then here you can see that the range of the summation is finite. So we'll representing it in this form as, if I am writing summation n equals to n1 to n2, means I am taking two finite ranges a raised to n, then the term will be a raised to lower range minus a raised to upper range plus 1 divided by 1 minus a, right? So if I am applying this rule, then what will be the value? here the range will be n equals to 0 to n minus 1. So the value of n1 equals to 0 and the value of n2 equals to n minus 1. Right. Now this value will be for a does not equals to 1. But if I am taking a equals to 1, then what will be the value of this a raised to n? Its value equals to capital N, because if I am taking here as 1, so 1 raised to n means n2 minus n1 plus 1. So if I am applying this formula in the above equation, then what is the value of y of n? Y of m equals to 1 by n, summation n equals to 0 to n minus 1, x1 of n, summation L equals to 0 to n minus 1, x2 of L, and the third summation is of k equals to 0 to n minus 1, right? Here the term is a raised to n, and if we will apply this rule, then there will be two terms, e raised to minus j 2 pi plus, if we will take in plus part as common, so e raised to j 2 pi k m minus n minus L divided by n. This one is the last equation, right? Now if I am using this, and if we are taking two cases, case 1 if we are taking a equals to 1 and the another case is case 2. So if we are taking a does not equals to 1. So if I am taking a equals to 1, then what will be the value? Higher value minus lower value. So this value minus 0, n minus 1 plus 0 and plus 1. So it will gives you the answer equals to, this summation will gives you the answer equals to n, right? Now if we will not taking a equals to 1, so it means if we will not taking a does not equals to 1, so we will apply this rule here. So if I am applying this rule, then what will be the answer of this summation? Answer of it equals to a raised to lower range means 0 minus a raised to upper range means n minus 1 plus 1, because n2 equals to n minus 1 and this one is plus 1, right? So 1 minus a. Now if I am putting this all the value here a as e raised to j 2 pi k m minus n minus L upon n. Here also e raised to j 2 pi k m minus k will goes over here. So the term will be like e raised to j 2 pi m minus n minus L upon n, e raised to j 2 pi m minus n minus L upon n, e raised to minus j 2 pi m minus n minus L divided by n, right? So if I am simplifying this, the value of any term raised to 0 means 1. The value of this equals to n minus 1 plus 1 means n, and n will be cancelled out. So this term will representing as e raised to minus j 2 pi into m minus n minus L divided by 1 minus this term, right? Now you can see that e raised to minus j 2 pi m minus n minus L. Now what is the meaning of this? The value of m minus n minus L means any integer number, and if it will multiply with minus j 2 pi, then its answer equals to always equals to 1. So the value of 1 minus 1 equals to 0 over here, so overall answer equals to 0. So if I am putting 0 over here, so this term will become 0. So this equation, this case does not possible. So the value of a should be equals to 1, and if I am taking a equals to 1, it will give us answer equals to n, right? So instead of this summation, we are taking n. So n will be cancelled out, so overall answer equals to this. So it will gives you the answer as, it's a convolution of these two terms. So y of n equals to summation n equals to 0 to n minus 1, x1 of n into x2 of m minus n plus. So this way we can prove this circular convolution. Thank you so much.